Hi, my name is Aline with Team 8. In this presentation, we will present our analysis of the social and environmental challenges of electric vehicle battery production and our recommendations for improvement. Team 8 offers a multidisciplinary analysis informed by expertise in data analytics, change management, energy efficiency, law, and training. Electric vehicles represent a way to reduce greenhouse gas emissions from the transportation sector. From the perspective of tailpipe emissions, they are a success. However, from the mining, manufacturing, and end-of-life perspectives, they represent unintended challenges. Mining conditions could include child labor and unsafe workplaces. The manufacturing process creates enormous CO2 emissions depending on the carbon intensity of the fuel used. At the end of life, batteries represent a huge investment in minerals and manufacturing that could be wasted. These problems will be amplified because of regulations requiring EV adoption.
We used a PESTLE framework to analyze the problem according to political, economic, social, technological, legal, and environmental lenses. For example, government policies requiring EVs will result in requirements for 2 billion vehicles by 2050. However, labor cost differences have led to China's dominance in EV batteries and other countries being 10 years behind. From a social perspective, vulnerable groups have been exploited in mining operations, and our dependence on the rare materials they are mining will be exacerbated by coming EV demand. Weak local laws result in unsafe mining practices for them, and the expected scale of future EV production will create enormous raw resource demands and waste. From a local perspective, government policies require greenhouse gas reduction and will result in increased EV use and needs for production. However, moving manufacturing locally would require either cheap labor or cheap renewable energy. Protective laws are inconsistent between countries, resulting in abuse, and revelations about that exploitation damage the reputation of manufacturers and drive interest in social responsibility. From a technological perspective, resource needs encourage reuse of materials and improvements in battery design. Making efficient and ethical use of those resources requires supply chain monitoring and recycling processes.
According to the PESTLE analysis from a global perspective, governments need to introduce import barriers and certifications that require disclosure of materials and processes and exclude or tax non-compliant products. Governments should require traceability of supply chains, enabling the tracking of greenhouse gas emissions, precious materials, and the monitoring of compliance with human rights. It is also necessary to subsidize grid energy for supporting new facilities in safe locations. This will enable safer working conditions and, in combination with cheap and clean energy use, will result in less labor costs. Funds for research and development needs to be established for alternative battery designs and innovative fuels such as hydrogen. And finally, government needs to mandate a scheme for a manufacturer-funded organization to collect and process used batteries. At a local perspective, we propose to establish a circular economy by improving battery longevity and creating a consortium to research and recommend improved battery designs for easier reuse and recycling across manufacturers. Furthermore, we propose to create supply chain transparency with sensors to gather data and store it in blockchain ledgers as a kind of passport for batteries. Finally, we propose to automate compliance of suppliers with sustainability and human rights requirements. This will be supported by artificial intelligence, which will monitor and audit supplier data and trigger consequences for non-compliance. These consequences include automated penalties, pausing of supplier contracts, specifying and monitoring corrective actions, and finally, switching to alternative suppliers.
Based on our analysis, governments provide rules to establish protection while leveling the playing field for competitors. as well as resources for implementation. In conclusion, we propose that governments need to establish import barriers and traceability requirements. They need to provide funding for green energy, research and development, and a scheme for used battery reuse and recycling. At a local level, manufacturers need to improve battery longevity, establish a consortium to manage the return, processing, and reuse of batteries, and establish automated data collection and compliance using artificial intelligence.